Alright, I welcome you into today's lesson. As usual, learning at ease. We're already in class. Today, we're going to talk about describing the geological structure of an area on a map. How would we describe the geological structure of an area? Previously, we discussed ways how we can give evidences on a topographical map, where we looked at different ways how we can give evidences. We talked about use of grid-defined system. We talked about use of place names. We talked about use of longitudes and latitudes. We talked about use of directions. We talked about use of bearings. We discussed previously a gradient. We saw how we can calculate the gradient on a topographical map. As I told you, we are discussing a topographical map because our map work is basically on a topographical map, and we said that this is a map that shows both horizontal distance and vertical distance. So today we are going to describe the geological structure of an area. How can we describe the geological structure of an area? First of all, geological or geology, this word refers to rocks. So we are going to discuss today how we can describe the rocks of a given area on a map. How do we know which rocks are on a given map? We are going to start by looking at the definition of rocks. A rock is an aggregate of minerals. Aggregate of minerals in solid state. In other words, to get a rock, we need to get a number of minerals. Minerals like gold, minerals like diamond, minerals like feldspar, a number of minerals. So when you put them up, we get a rock. So we have different types of rocks. We need to know them, though we shall expound more about them in physical geography. But briefly, a rock is an aggregate of minerals, and a mineral is an aggregate of elements. A mineral is an aggregate of elements, and the elements is the smallest particle of matter, and the element is the smallest particle of matter. So when we aggregate minerals, we get a rock. We have a number of rocks. As we shall discuss them. These rocks, before you discuss them on the map, you should know the types of rocks we have. So basically, we have three types of rocks. We have igneous rocks. We have sedimentary rocks, and we have metamorphic rocks. So any area can have any of those, or can have all of them. So on the map, how do we know that an area has igneous rocks, an area has sedimentary rocks, an area has metamorphic rocks? So to have a simple review of igneous rocks, these are rocks that are formed due to the cooling and the solidification of molten materials. These are rocks formed from molten materials, e.g. lava, magma. Rocks that come from lava or magma, or rocks formed by crystallization. We have sedimentary rocks. These are rocks that are formed due to accumulation and lidification or cementation of weathered particles. So this is the rock that comes from sediments. These are broken particles or fragments. If I break this, then this is a sediment. Now if I get a number of sediments, I put them together to form a rock. To lithify, lithification comes from lithosphere. And lithosphere comes from a Greek word lithos. Lithos means a rock. So lithifying meaning getting these particles, putting them together. We can use minerals like silica. Silica is sticky, so it can put these particles together. That process is called lithification. So sedimentation is going to come from getting a number of sediments, we put them together, then we get a sedimentary rock. Then a metamorphic rock, this is a rock that comes from changes. One rock changes from one type to another. If it is subjected to heat, we get heat, we have pressure, we have both heat and pressure, heat plus pressure. So when a rock changes, maybe color, you can have change in color, change in color. If a rock changes color because it is subjected to heat, it becomes a metamorphic rock. If a rock changes its resistance, a rock which was soft, which was hard, is now soft because of maybe heat, that is a metamorphic rock. Or a rock can change its shape because of too much pressure, it becomes metamorphic rock. So if you are asked to describe the geological structure on a given area, basically we are going to be discussing it in terms of igneous rocks, sedimentary rocks, metamorphic rocks. Now, there are some tips we need to be knowing before we discuss the geological structure of a given area shown on the map. How do we know that the area has igneous rocks? How do we know that the area has sedimentary rocks? How do we know that the area has metamorphic rocks? So we have a number of elements we should focus on to tell. One, we can use landforms. These are the tips we can base on to tell the geological structure of an area. Landforms. Landforms. So on the map, check on the landforms that are given on the topographical map. We know that volcanoes, if there is a volcano on the map, we know that a volcano is formed due to cooling and solidification of molten materials. That means a volcano gives us volcanic rocks or igneous rocks. So if you check on the topographical map given to you and you see that there is a volcano, automatically you will say that the area has volcanic rocks. There is a crater. A crater, this is a funnel-shaped depression that is found on top of a volcano. On the map, always we show a crater by these lines, these ones. You always find them on the map. These ones indicate a crater. And they are always used to depict the slope or the direction of slope of an area. But we should know that when we see this, we are seeing a crater. A crater is a funnel-shaped depression that is found on top of a volcano. So a crater is always having igneous rocks, and the craters are very common on topographical maps. So that one can also help us to know that the area has these types of rocks. Another thing we can use is man's activities. Man's activities. We can base on man's activities on the map. Man's activities. If there is quarrying, quarrying is always done on igneous rocks. It is always on igneous rocks. Why? Because these rocks are hard. These are hard rocks, especially granites. They always deal in granite. So people always break those rocks to use them in building and construction. So if there is quarrying in an area, automatically we shall know that they are igneous rocks. Why? Because igneous rocks, one of the characteristics of igneous rocks, they are hard in nature. So how do they help man? Because they are hard in nature. They are used in construction. Construction of foundations, construction of roads. We always use igneous rocks. So check on the map. If there is a quarry, that means there is quarrying somewhere. So basically quarrying is done on igneous rocks. So we can say that there are igneous rocks in an area evidenced by presence of a quarry or presence of quarrying, which is basically done on igneous rocks. Another man's activity, it can be mining. If you see there is limestone in an area or cement factories in an area, then we shall know that there is limestone. Limestone. So if there is cement works in an area, we shall know that there is limestone. And the limestone is a sedimentary rock. This is a sedimentary rock. So therefore, mining or cement works can depict the presence of limestone rock, and limestone rock is a sedimentary rock. Limestone is a sedimentary rock. We shall discuss these rocks in physical geography in details. But these rocks we are talking about, they are here. For example, this one is a sedimentary rock. This is a sedimentary rock, limestone. And this one, it is, when you look at it, the particles were just joined. That means we brought sediments and they were put together. When you look at it, the particles are jointed. So it is a sedimentary rock. Then we have another rock here. This one is called slate. This one is slate. It is very common. It is used in decoration. This one is called slate. Slate is a metamorphic rock. Metamorphic rocks are always characterized by sheet-like layers. These ones are called foliates. So if you look at this rock, it is foliated. It has layers. So this one is a metamorphic rock. It is slate, and the slate comes from limestone. When limestone is subjected to great pressure, it forms this one. Limestone is a sedimentary rock, but when a sedimentary rock changes color, it changes resistance, it can change its shape, it gives us metamorphic rock. So when you get, it is claystone. So when we get claystone, we subject it to pressure, we get this type of rock. There is another type of rock, quartzite. Quartzite, this one, it is called quartzite. It's called quartzite. Quartzite is also a metamorphic rock. Quartzite comes from sandstone. When sandstone is subjected to heat, we get quartzite. We have another one here, quartz. It is quartz here. It is quartz. It is an igneous rock. When you look at the particles of this rock, they are different from the particles of this. These ones, you see that they are jointed sediments. But this one, when you look at it, the particles are crystalline in nature. So this one is formed by crystallization. Particles are very fine. This one, particles are jointed. Another tip we can base on to tell the type of rock in an area, we can look at drainage. We can look at drainage of an area. Drainage of an area. Check the flow of rivers, especially. When you see very many surface rivers which are flowing on the earth's surface, these ones depict that down there the rocks are impermeable. So the permeability of the rock determines the type of rock. For rivers which are flowing over the earth's surface, it means down there the rocks are impermeable. And the impermeability of the rock depends on the nature of the rock. So hard rocks are always impermeable. So we ask ourselves, which rock could be impermeable here that does not allow these rivers to flow from within the earth's interior? And that one is automatically igneous rocks. So I can say that the area is having igneous rocks, and this is based on the very many surface drainage features due to impermeability of the rock structure of that area. So if the area has permeable rocks, that means we shall have very many underground rivers. Why? As water flows on the area, the ground, it percolates instead. So if we see very few surface drainage features, then we shall know that the area is having permeable rocks. And the permeable rocks are basically sedimentary rocks, because sedimentary rocks, since they are formed by sedimentation or lithification, meaning those particles, when I bring a particle, I add on another particle, there are spaces which can allow water to pass through. So that one can tell us that the area has the area has permeable rocks, and these are basically sedimentary rocks. Another thing we can base on, still on surface drain or on drainage patterns. We can use drainage patterns to tell the nature of the rocks or the structure of the rocks in the area. There are drainage patterns. Drainage pattern, this is the outflow, the plan or the layout of rivers with their tributaries. So when we find an area having a dendritic pattern, that is a pattern where rivers, tributaries join the main river at almost at acute angles. So this one means that the area has uniform rock structure. So the rocks are hard. So this river cannot come direct. That means it has to look for areas which have soft rocks. So an area with the dendritic pattern can depict the presence of igneous rocks. These are hard rocks. These are hard rocks. So we have said drainage, in terms of surface drainage, it indicates igneous rocks. Underground drainage, it indicates sedimentary rocks or permeable rocks. And then drainage patterns can also help us to know the type of rock. If they are if it is dendritic, then we shall know that these are igneous rocks. Then we can also look at where we have very many rivers, we shall know. So where we shall look at an area having many rivers, zero drainage, lakes, ocean, swamps, wetlands. These areas are having sedimentary rocks. Why? Because sedimentary rocks in these areas, especially mechanically formed sedimentary rocks, where a rock is broken down, then it is washed, it is carried by transportation agents like running water or moving ice. But now you find that these rocks, these particles are deposited in these lakes or these rivers. So rivers, lakes always have sedimentary rocks mechanically formed. For example, we shall always find in lakes siltstone. Siltstone is a sedimentary rock that comes from silt. These are fine particles. So when a river erodes materials, deposits them in those lakes, they are going to find that we shall get a rock which has very fine particles, and that is siltstone. Sandstone is also another sedimentary rock mechanically formed. This one, it is formed by medium-sized particles, sand particles. So sand particles, you find them in lakes, you find them in rivers. So when those particles are lithified, they are put together, we shall get a sedimentary rock known as sandstone. We shall also have gravel. These are angular rock particles. Gravel, there are some rocks which are made up of large particles, like a gravel. But these ones are always found in seabeds, they are found on riverbeds. Why? Because when they are eroded as the river flows, they are deposited down in there. So when they get deposited, they are lithified and we get sedimentary rocks. So swamps, those are collectional centers for eroded materials. So even in swamps, if the area you see that the area has seasonal swamps, automatically we shall know that they are sedimentary rocks mechanically formed. If you see the area has a lake, automatically there must be sedimentary rocks because they are going to be eroded and deposited in those areas. Areas with the rivers, automatically they are sedimentary rocks. This one, sandstone, siltstone, mudstone, shale. Shale comes from clay particles. All those claystone. All these rocks are found in areas which have rivers, lakes, ponds, oceans. Those ones are very common there. So we can use landforms to tell the types of rocks. We can use man's activities. We can use drainage of an area to tell the rocks that are found in an area. The rocks that are found in an area. The rocks that are found in an area. So geology, we are basically looking at the rocks that are very common in an area. So today's lesson, we have been looking at describing the geological structure that is shown on the topographical map. Geology, they are basically talking about rocks. We have said that the rocks are basically igneous, sedimentary, metamorphic. There are also some other hints we can use to tell the geological structure of an area. For example, there are areas we know that these areas have these types of rocks. For example, in Tanzania, there are areas called Ambon, with Ambon caves. There are areas which have got limestone features. Like the Amboni caves, these caves were formed by carbonation. These caves, these areas in Tanga, they have limestone regions. They have limestone rocks. And limestone rocks have got calcium carbonate. So calcium carbonate reacts with the carbonic acid. That is when water mixes with the CO2, they form a carbonic acid. So this acid reacts with the calcium carbonate and then form calcium hydrogen carbonate, which is always taken away in solution form. So when you see these caves on the map, they are always put on the map. They can put Amboni caves or even other areas where we know that they are sedimentary rocks, they are limestone regions. So now when you seek Amboni caves, I can tell that we're having sedimentary rocks, basically limestone, due to the presence of Amboni caves, which is an area that is known for having limestone rocks. Very many things we can use to discuss. We can also talk about, I talked about the features, we can also talk about depositional features. If you see the area has they bring maps and they put sandy dunes. In areas with sandy dunes, automatically we shall be having sedimentary rocks. The depositional features, they can also bring a map which has coral reefs. They can bring a map which has coral reefs. If you see that they are coral reefs, automatically we know that coral reefs have got organically formed sedimentary rocks, calcareous. They came from remains of animals that were rich in calcium, and those were polyps. So when I see the map has coral reefs, I can know that they are organically formed sedimentary rocks. If I see Amboni caves, I shall know that they are chemically formed sedimentary rocks. If I see volcanoes, I will know that these are igneous rocks. If I say crater, automatically I will know that these are igneous rocks. If I look at the drainage of the area and there are very many surface rivers, I will know that automatically these are igneous rocks. Why? Because they are hard rocks which cannot allow water percolate. Where I see rivers, oceans, ponds, and swamps, zone swamps, I will automatically know that these areas have got sedimentary rocks. Why? Because they are deposited in those areas. So as I'm winding up, I told you we have books here. There is this one of survey. It is a very good book. It talks about surveying. It has elementary surveying and professional surveying. So you can buy it. And there is another one, this one. All what we are discussing here is found in this book. It is found in this book. In case you need it, you can send me a text. You get the copy. All the work we are discussing, the work I've discussed, much of it is here. And you can grab yourself a copy and then be an expert in map reading. So that has marked the end of today's lesson. Thank you for attending. Subscribe on our YouTube, Learning at Ease, for more lessons. Facebook page is Learning at Ease. Subscribe, like our pages, like our work, comment, and be following. Thank you for following. Wish you well.